Hi, dear children. Now I want to talk something more on the relay. The relay are very important. That day I talk about the relay, and the core of the relay should be a magnet, which is a soft metal. The hysteresis loop should be thin, and retentivity should be almost zero. And you understand why, and you'll understand it more here. See, in olden days, relays were used in telephone, say till 1980. Then C dot came, and then all became digital IC, all IC chips, integrated circuit chips. So this help and relay are wiped out. They are replaced by the chips. Very high frequency, very efficiency. So another main work of a relay is to control heavy current consuming device with a relay. For example, to start the car, the self-starter to crank start the car by a driver from the dashboard. This needs 60 ampere, and you cannot take 60 ampere wire to the dashboard. Same with the horn also. We cannot blow horn by taking the wire of the horn which consume current to the dashboard or to the steering wheel. Okay? So now here, see, this is a car battery. It is about 30 kg, very heavy, X-type battery, plus and minus. See the minus is negative. The negative is a heavy wire, very thick wire, as big as this stick here. So this is to the ground. And remember, in the car, in any automobile, the ground, any metal part of the car are grounded, which means all metal part in the car, in automobile, they are negative. So remember that. So now this is the horn. The horn is in front in the grill. That means near the front end the horn will be there. And see now. To blow this horn we need about 8 ampere, and the wire should be 4 mm. I cannot take 4 mm to the dashboard and then press the button. This will be very cumbersome for the wiring of the car. So see now, this plus it goes here, and then now it goes to the relay. See, this relay, the spring is holding the relay here. Now, when the driver press the button in the steering wheel, see this is very thin wire, 1 mm wire. Because why only 0.5 ampere is needed to magnetize the core, that soft iron, and when it get magnetized, it will pull this. When it pull this, see, what is this? This is heavy wire carrying 8 ampere. When it pull this, it will blow the horn will blow. Now, you should be very careful in buying relay for your car. If you buy cheap relay, this relay sometimes become a permanent magnet. So what happens when the driver horn the car, even when he release the button, the horn will keep on hounding. It will disturb the traffic, it will disturb the people on the roadside. Because why? This is in contact. Why? This has become more or less a permanent magnet. So be careful. This is one. So this is the beauty of a relay. See, small current can control heavy current, and heavy current can be very concise near the battery. So now we come to this one here. This one also, relay, is very important in speaker. I think you might have heard of the best speaker in the world for your music. That is Bose speaker. And you should know Bose is from India, okay, and he is world famous. And the speaker he made, they are used worldwide. So to understand about the coil in the speaker, I will show you this one. Okay. So this is a speaker I've taken from a science dictionary. See, this is the diaphragm which vibrate and it gives you sound, diaphragm. These two wires are to the coil. This one wire in the diaphragm is connected to the coil, and then this one. So when there is a music from the sound system, the coil will keep on oscillating. Why? Because the sound is sine wave, and this coil will move up and down, and this is the core of the magnet, the core of the magnet. So here you understand it will be, okay. See, this is the diaphragm, and this is the coil. And the coil, the wire will go here from the output of the sound system. Another wire will come here, so it will go here. So what happened then when the wire are connected from the sound system, this coil, there is what, this one will be, or the soft metal will be here. See, the soft metal will be here, and this will vibrate. So when the speaker vibrates, it gives you sound. Now, this coil, this core here should be also a soft metal. If it is soft metal, the retentivity is zero almost zero. Coercivity also almost zero. So whatever movement of the coil is the movement of the sound signal coming from your sound system, from your amplifier. If the core is very bad, then the sound system will be distorted. So that is about the relay. I think you understand this. This is very important. The soft metal put here is the best for the good movement of the speaker. So now next we will come to this one. We'll come to this one. Before I give you the problem, we will come to this one. I will solve your problem. I ask, why in cyclotron we use right hand rule, and in current electricity we use left hand? I will give you the answer. It is very simple. I am very sorry that I could not get your feedback because WhatsApp problem is their limitation. We don't have those question answer types. So anyway, this is right hand rule because it is dealing with proton. This is left hand Fleming rule because this current is in this direction. But remember, what is a current? A current is just a concept in the book. The main movement of this current is due to electron coming in opposite direction. So one deal with charge, positive charge proton, it should be right hand, and the one that deal with electron, because this is current but electron is opposite, so it should be what? A left hand rule. So this is proton in this direction, and here the current is in this direction, but the electron is coming from the negative of the battery to positive. So here, this thing. So now the problem. This is the problem. The inventor of cyclotron, they are E.O. Lawrence and M.S. Livingstone, 1934. So now 220, 1930, 86 years almost 100 years. So now we will keep you a problem. So we are now indebted to all the great scientists for this. So now the problem. CBSE Part 1, Class 11, page 142, you can see. A cyclotron oscillator frequency is 10 megahertz. That means 10 into 10 to the power 6 hertz. So what should be the operating magnetic field for accelerating proton? One question. If the radius of the disc is 60 centimeter, what is the kinetic energy in this million electron volt of the proton beam in the accelerator? This one I will not do it for you. Don't look here also. whatever I have done, please find out the correct equation, so that you will find you'll find what? You'll find the energy, and you will also find the operating magnetic field. Please do it yourself, because I don't want spoon feeding. So the answer I'll give you, 0.66 Tesla, the magnetic field, the one that is perpendicular to this is zero point 0.6 Tesla magnetic field. And then kinetic energy, I'll have to help you a little bit. Kinetic energy is mass of the proton into B square, half mp B square. So what you have, mp is supplied, you only have to find B square. Please do it yourself. So it will be 7 million electron volt. And see the beauty of CBSE question. They have given you also joules. See, I think they have given you somewhere joules value. 1 million electron volt is 1.6 into 10 to the minus 13 joule. Because this one will be joule. And if they don't supply this, then like in NEET problem, they never supply this data. They want you to memorize. That is not good. But here, see, 1 MeV, 1 MeV is given. It is about where is it? You will get it here. 1.6 into 10 per minute. So this will be in joule. You divide by this, you'll get it. So the answer is 7 MeV. So please don't read this. You try first by your own, and all the best for this result. Thank you.